In this video, we learn how to find the powers of numbers which are close to 1 using binomial expansion. Let's do that with an example. Let's start with 0.95 to the power 5. Now, one way to do this would be to just multiply 0.95 by itself 5 times. Another would be to rewrite this as a sum or difference. We can write 0.95 as 1 minus 0.05. This raised to the power 5 gives us the same thing. Now this looks familiar. This is 1 minus x to the power n. Here x is 0.05 and n is 5. So if we expand this using binomial expansion, this becomes 5c0 because it's nc0. So 5c0 x to the power 0 minus, because the signs alternate, we have a negative here, minus 5c1 x to the power 1, then 5c2 x square and so on. So we have these 6 terms. We are adding 3 and subtracting 3. Each term has a coefficient which we can easily find. 5c2 is 10, 5c4 is 5. So these coefficients are manageable. What about the powers? X to the power 0, x to the power 1, 2, 3, 4. Well, these powers are of 0.05, not 0.95. We know the powers of 5 and we know how to work with decimals, so we can figure out these powers as well. So this is a difficult task, but breaking it down into 6 simpler tasks is still manageable. So this becomes, if we replace x with 0.05, we get 5c0 0.05 to the power 0 minus 5c1 0.05 to the power 1 and so on. So what are these terms? Let's figure them out. 5c0 is 1, 5c1 is 5, 5c2 is 10, 5c3 is also 10, 5c4 is 5 and 5c5 is 1. So now we have these 6 terms. The coefficients are 1, minus 5, 10, minus 10, 5 and minus 1. And the powers are 0.05 to the power 0, 1, 2, 3, 4 and 5. This is probably the smallest term because this is 0.05 to the power 5. This will have 10 decimal places. 5 to the power 5 is 3125. So it's going to be 0.00003125. This is probably the largest term because all of these terms are less than 1. This is exactly equal to 1. But let's see what these terms are. This is 1 because we're raising it to the power 0. This is 5 times 0.05. This is 10 times 0.05 squared. So this will have 4 decimal places. 5 squared is 25. This is 0.0025. What about this one? This is 0.05 to the power 3 or cubed. So this is 125 with 6 decimal places. So 0.000 and then 125. This is multiplied by 10. Then we have 5 times 0.05 to the power 4, which means 8 decimal places. 5 to the power 4 is 625. So this is what we get. And finally, we have 0.05 to the power 5. This is 0.000003125. So this will have 10 decimal places. All right. So should we multiply these terms? We have 1 minus 5 times 0.05. That's going to be 0.25 plus 10 times 0.0025. This will increase this number, but not by a lot. This is 0.025 minus 10 times 0.000125. So we just shift the decimal place by 1. So this is 0.00125. Then we have 5 times this, a very small number, minus this number as it is. Again, very small, insignificant number. Now, if we wanted an exact value of 0.95 to the power 5, we could have continued. We could have added and subtracted these terms. We've got these 6 decimal terms. We'll figure out 0.95 to the power 5. But we don't want the exact value. We can easily get the exact value by using a calculator. What we want is an approximation. So which of these terms would you pick if you wanted an approximate value of 0.95 to the power 5? Well, if you wanted a very rough approximation, you can just take the first 2 terms. It's 1 minus 0.25, that's 0.75. So this raised to the power 5 is 0.75 approximately. If you wanted to be more precise, you could take the first 3 terms. You can add this 0.025 to it. That's going to be 0.075. So the approximation is now much better. Then you can keep on adding these terms and fine tuning your answer. So how many terms should you pick? Well, the correct answer is it depends. It depends on how close to the exact value you want your approximation to be. And also it depends on how quickly you want to get to that approximation. In most cases, the first 2 or 3 terms will give you a fairly good idea. So let's do the same for this one. Let's take the first three terms and ignore the rest. These terms are way too small compared to these three. So it doesn't really matter whether we add or subtract this value or this value. So let's ignore these three and let's add the first three. This is 1 minus 0.25 plus 0.025. This is an approximation. 1 minus 0.25 is 0.75 plus 0.025. That's going to be 0.775 as we have calculated. So this is an approximation of 0.95 to the power 5. Now, we wouldn't have bothered to expand 1 minus x to the power 5 fully. We would have just taken the first three terms, simplified them, and we would have reached to 0.775. But this is what we can do the next time we're approximating a power which is close to 1. Now, before we move on to the next one, let's check using the calculator how close this approximation is to the exact value. The exact value comes out to be 0.7737809375. If we divide this, we'll figure out that we're only 1.5% off. This error is very manageable. And this error reduces the more close to 1 the number is. Let's take another example. This is 0.99 to the power 5. Pause the video, try expanding this using binomial theorem. Okay, let's do this together. This can be written as 1 minus 0.01 to the power 5. Again, using 1 minus x to the power 5, we'll have these 6 terms. If we expand this and plug the value of 0.01, this is what we get. Same coefficients, 5c0 is 1, 5c1 is 5, 5c2 is 10, then 10, 5 and 1. But this time, we're taking the power of 0.01, not 0.05. So let's see the difference. This is 1 minus 5 times 0.01 plus 10 times 0.0001 minus 10 times 0.01 cube. That's going to be 6 decimal places. Here we have 8 decimal places and here we have 10 decimal places. Now if you multiply the coefficients, we have 1 minus 0.05 plus 0.001 minus this term, then plus this term minus this term. So we can clearly see that first 2 or 3 terms will give us a very good approximation. 1 minus 0.05, that's 0.95. That's the first approximation, but we can fine tune it. We can take the third term as well. So that's 0.951 and we can ignore these 3 terms. So this will become 1 minus 0.05 plus 0.001. This is an approximation. So our approximation taking the first 3 terms of 0.99 to the power 5 is 0.951. Again, let's check using the calculator how close we are to the exact value. The exact value is 0.95099000499. This is very, very close to 0.951. Now, if we divide, we get that the error is 0.001%. This is almost exact. So we're taking the first 3 terms and we're getting an almost exact value of 0.99 to the power 5. That's the power of binomial expansion. Now, let's try one more problem. This time, let's move to the other side. Let's raise 1.02 to the power 5. Pause the video, try this yourself. Take the first 3 terms. Okay, so this is 1 plus 0.02 to the power 5. 1 plus x to the power 5 will give us these 6 terms. We're approximating, so we'll take the first 3. So the approximate value of this is 5c0 0.02 to the power 0 plus 5c1 0.02 to the power 1 plus 5c2 0.02 squared. 5c0 is 1, 5c1 is 5, 5c2 is 10. And we can raise 0.02 to the power of 0, 1 and 2. This is 1, this is 5 times 0.02, that's 0.1. And 10 times 0.02 square, that's 10 times 0.0004, which becomes 0.004. So 1 plus 0.1, that's 1.1, plus 0.004, that's 1.104. That's the approximation for 1.02 to the power 5. And how close we are to the exact value? Exact value is 1.104. It matches till 3 decimal places, 0.808032. We are 0.01% off, which is again almost exact.